Hi, my name is Clarissa Trapp, and today I'd like to talk to you about PREMIS, or Preservation Metadata Implementation Strategies. PREMIS is an international standard for metadata that supports the preservation of digital objects and ensures their long-term usability. Today, PREMIS is commonly used in the digital preservation world, but rarely seen. The average person browsing a public-facing repository will not receive PREMIS information when they query the database. Instead, the primary uses of PREMIS are for repository design, repository evaluation, and exchange of archived information packages among preservation repositories. What is preservation metadata? Preservation metadata is the information a repository uses to support the digital preservation process. Can include a wide variety of data about a digital item, but primarily it includes provenance information, technical information on the digital objects to be preserved, and rights information, also known as administrative information. Preservation metadata should establish the authenticity of the object and keep a history of changes made to it and who made those changes. It should also document relationships between files. Because digital files are dependent on hardware and software to render them usable, preservation metadata should also include technical specifications and needs of the item. Usability depends on this. Finally, rights metadata indicates who may access or copy the information and under what circumstances that can take place. Descriptive information can be found in preservation metadata, but description is not the primary goal of preservation metadata capture. If your institution is working with digital objects, and especially if it plans to follow best practices to preserve those objects, your institution should consult PREMIS. One, using PREMIS should help you maintain long-term access to digital materials. You'll have the information you need to render those digital objects and to ensure that the files are not deteriorating. Two, PREMIS is useful for repository management and maintenance, of course. Since one of PREMIS's most important functions is to aid in repository design and evaluation, it will also prove useful for managing those repositories once PREMIS has been implemented. 3. PREMIS protocols should help you record your digital objects' histories. You'll know what events have changed or at least affected those objects and when they happened. 4. Conforming to PREMIS should build trust with users and help you gain Trusted Digital Repositories designation. If you accept digital files from outside entities, those depositors will want to know that their materials will be maintained and displayed correctly. In fact, you may have a legal mandate to preserve those digital objects, so you will want to use PREMIS to ensure that you are following those legal agreements and instilling trust in your depositors and users. 5. Finally, if you want to share information, you will likely find it easier to exchange information packages with other systems or institutions if you are both using the same metadata schema and the same definitions. The PREMIS schema is the de facto international standard for preservation metadata. So, how did it come about? By the 1990s, information professionals began to recognize a need for securing long-term access to digital objects and records and create trusted digital repositories. One of the first attempts to formally address this was the Task Force on Archiving of Digital Information, formed in 1994 by Research Libraries Group, or RLG, and the Commission on Preservation and Access. By 1999, the Consultative Committee for Space Data Systems released a draft of the Open Archival Information System, or OAIS, conceptual framework, which became ISO 14721 and the de facto conceptual standard for digital preservation. Information professionals began adopting it, and soon after, the Online Computer Library Center, or OCLC, and the Research Libraries Group collaborated on a working group to create a preservation metadata framework from the OAIS reference model that would provide a broad, agreed upon, and shared framework that identified the types of information that should be associated with an archived digital object and could be implemented by anyone engaged in digital preservation. The Preservation Metadata Framework Working Group was charged in 2000, and in 2002, They issued their findings and a proposed list of metadata elements, which provided a path forward to implementing the OAIS conceptual framework, but did not get enough detailed information on how to do that. In 2003, OCLC and RLG asked an international group of experts to develop practical guidelines for putting the preservation metadata framework into use, and the Preservation Metadata Implementation Strategies, or PREMIS, working group got to work. According to Priscilla Kaplan and Rebecca Gunter, who chaired the group had 5 objectives. 1. Define an implementable set of core preservation metadata elements with broad applicability within the digital preservation community. 2. Draft a data dictionary to support the core preservation metadata element set. 3. Examine and evaluate alternative strategies for the encoding, storage, and management of preservation metadata within a digital preservation system, as well as for the exchange of preservation metadata among systems. 4. Conduct pilot programs for testing the group's recommendations and best practices in a variety of system settings. And 5. Explore opportunities for the cooperative creation and sharing of preservation metadata. The PREMIS working group divided into 2 subgroups. The core elements subgroup developed the elements called semantic units and a data dictionary. The implementation strategies subgroup developed suggested strategies for encoding, storage, and management of preservation metadata in institutions' digital preservation systems, which they tested through several pilot programs. Because practical implementation was the goal, the group surveyed 70 libraries and cultural heritage organizations around the world to understand the varied needs of organizations engaged in digital preservation and used the answers to construct their final suggestions. The results became PREMIS. After the PREMIS working group finished their final report, they disbanded. The PREMIS preservation metadata maintenance activity took its place, and the standard is hosted by the U.S. Library of Congress in the Network Development and MARC Standards Office at www.loc.gov/standards/premis. The site contains the current and past data dictionary and schemas, information on maintenance of the standard, documentation on conformance to the standard, examples for implementation, lists of tools to use with the standard, supporting documentation, and notices of PREMIS news. The editorial committee directs PREMIS activities, including deciding when to revise the schema. Implementing institutions and interested parties can join the listserv for the PREMIS Implementers Group, or PIG, if they like. Users may submit errors and suggested revisions through a web form found at the PREMIS website. Speaking of revisions, there have been several versions of PREMIS since 2005. Some revisions were minor clarifications or additions to the schema and data dictionary. Others were major changes. PREMIS Editorial Committee has documented these revisions through the PREMIS website for our reference, and the current version is version 3.0. PREMIS is an extensible markup language or XML schema, but a significant update, PREMIS OWL, debuted in 2011 while users were working with version 2.1. OWL, which stands for Web Ontology Language, is a semantic web language based on Resource Description Framework, or RDF. So PREMIS OWL provided a way to encode PREMIS using RDF. Let's talk about some of PREMIS's features, strengths, and weaknesses. PREMIS is an XML schema, though PREMIS OWL allows it to be encoded in RDF. You could also record PREMIS metadata in CSV files or encode it as JSON if you needed to. It can join other standards such as MODS, METS, Dublin Core, EAD, etc. to cover metadata needs outside of its scope. The metadata lives separately from a digital object, and this means metadata and files must both be tracked through any migration. You cannot assume they'll stay together. Depending on your project or your institutional needs, you may see this as a strength or a weakness. PREMIS is highly adaptable. Strength. and is meant to be customized to your institution's needs, so you can use the pieces of it that best apply to your situation. On the other hand, this means that it is not an out-of-box solution to digital preservation. No one would implement each element of the data dictionary and be confident that they were meeting their institution's preservation needs. Some organizations will only use specific parts of PREMIS, and others will find that it doesn't provide enough options to store all information needed to preserve their digital assets. This need to customize may also prevent smaller cultural institutions from adopting PREMIS because they simply do not have the resources to implement the schema. Because PREMIS is meant to help design repositories, much of the metadata should be captured or pulled in automatically if the repository is designed correctly, and you should not have to populate entire individual PREMIS records for each digital object in a repository manually. If you did, the task would not be scalable. There is now a robust user community, so finding help or people with experience to assist with implementation questions is easy. It's widely accepted, and you can import and export PREMIS from preservation platforms like Archivematica. So, how does PREMIS work? PREMIS is composed of entities and semantic units. Entities are main categorical requirements of preservation metadata, and semantic units describe the properties of entities and are transferable to another repository. Note, PREMIS uses the term semantic unit rather than field or element. The PREMIS Data Dictionary describes these semantic units. Initially, PREMIS had 5 entities. In versions 1 and 2, the entities or main categories of information were intellectual entities, objects, events, agents, and rights. Technically, intellectual entities, which could be a book, database, work of art, or software, were considered out of scope of PREMIS because they could be described and retrieved without preservation metadata. In version 3.0, intellectual entities were eliminated as an entity and folded into objects. So there are only 4 entities now. Users can now choose whether to specify intellectual entities in or outside of PREMIS. Let's look at the PREMIS data model. The model, which is pretty simple, demonstrates how each of the entities relate to each other. Objects, which are on your left, they're discrete units of information, and they can include an intellectual entity, a representation, as in the set of files and structural metadata needed to fully render an intellectual entity, a file, or a bit stream. So objects can relate to events, rights, and other objects. Events are actions that involve or affect at least one object or agent associated with or known by the preservation repository. An agent can be a person, organization, or software program or system associated with events in the life of an object or with rights attached to an object. A rights statement declares any rights or permissions that pertain to an object or agent. And you can also see that an environment is a subordinate characteristic of an object. And the environment is the technology, like the software or hardware, that supports a digital object so that the object can be run or viewed. Environments are generally considered intellectual entities, but they can act as agents. And environments placed in the data model is also new in version 3.0. The data dictionary takes the relational model in the last slide and provides details needed to implement the semantic units that map to the entities. For the PREMIS editorial committee, these semantic units comprise metadata that support the viability, renderability, understandability, authenticity, and identity of digital objects in a preservation context. They represent the information most preservation repositories need to know to preserve digital materials over the long term. They emphasize implementable metadata, rigorously defined, supported by guidelines for creation, management, and use, and oriented towards automated workflows, and embody technical neutrality, as in there are no assumptions made about preservation technologies, strategies, metadata storage, management, etc. Let's take a look at those semantic units. You can see that the units are listed hierarchically. The information in parentheses following each semantic unit indicates whether the element is mandatory with an M or optional with an O, and whether it is repeatable with an R or not repeatable, NR. Subunits under each semantic unit are called semantic components. When components are present, the semantic unit doesn't have a value of its own, but instead acts as a nest for the components. For example, under the object entity, semantic unit 1.1, the object identifier has two components underneath it, the identifier type and the identifier value. In the example XML shown at the top right, the object identifier semantic unit holds the type and value components, and the components have values. In contrast, you can see the semantic unit 1.2 object category does not have components, so it would not hold a value. The object entity contains the most semantic units and components by far. The object entity's semantic units, highlighted in bold, are object identifier, object category, preservation level, significant properties, object characteristics, original name, storage, signature information, environment function, environment designation, environment registry, relationship, linking event identifier, and linking rights statement identifier. Event entity semantic units are a much smaller set. They are event identifier, event type, event date time, event detail information, event outcome information, linking agent identifier, and linking object identifier. I forgot to mention when introducing how to interpret the semantic units that each semantic unit or component is formatted in camel case. That is, other than the first word of each unit or component name, each subsequent word that comprises the name is capitalized, but all words run together. There are no spaces between them. In semantic unit 2.1, the I in identifier is capitalized in the unit name event identifier. Agent entity semantic units are agent identifier, agent name, agent type, agent version, agent note, agent extension, linking event identifier, linking rights statement identifier, and linking environment identifier. By now, you are probably noticing that those linking semantic units are really common under each entity, and they allow for the statement of relationships between entities as shown in the data model. The rights entity semantic units are short and sweet. There are only two: rights statement and rights extension. However, the semantic components underneath rights statement are extensive. Here is an example of an entry in the data dictionary. The name of the semantic unit appears at the top, and semantic components are listed beneath that. Other attributes included are definition, rationale, data constraint, which often refers to a controlled vocabulary, object category, applicability, examples, repeatability, obligation, creation or maintenance notes, and usage notes. You'll notice that if an object category is designated, the information underneath it applies to the object selected. You will not find all attribute options under all entities in the data dictionary. They are used as needed. So far, I've covered what PREMIS is, why you should use PREMIS, and given you an overview of how it works. And you may be a little overwhelmed and wonder if it is something that you need to start learning now. If you are a repository manager, then you need to know how to apply PREMIS. Depending on your institution, you may use it to implement new repository platforms and processes, or you may use it to evaluate your current repository. Since PREMIS is nearly 20 years old, the likelihood is that if you manage a repository, you are already aware of this. The other group of information professionals that should have some knowledge of PREMIS are data managers and digital preservationists. Understanding the types of data that PREMIS requires to be captured for preservation is always useful. On the other hand, you may not have much to say in how your institution uses PREMIS in that role. Instead, this understanding may help you if you are called on to help evaluate preservation processes or talk to your repository managers. The rest of us should know what PREMIS is and that it exists, and have a general idea of what sort of metadata are used for digital preservation. PREMIS emphasizes conformance with its standard, as in the action of conforming according to some pattern, model, or instruction. PREMIS promotes a certain level of institutional individuality, but in order for data between institutions to talk to metadata in other institutions, the metadata must conform. Here's an example of conformance to PREMIS. If a metadata element shares the name of a PREMIS semantic unit, it must also share its definition. If a metadata element shares the definition of PREMIS semantic unit but does not share its name, the repository must establish a mapping between the metadata element and its corresponding PREMIS semantic unit. In 2016, levels of conformance were introduced. At level 1 conformance, an institution has internal preservation schemas and can provide documentation showing how their schema maps to PREMIS. At level 2, those schemas must be able to export as PREMIS metadata. At level 3, the institution uses PREMIS as its schema and requires no extra mapping or conversion. After some hand-wringing and a slow implementation start in the mid-2000s, PREMIS is now widely recognized and used. This means that much of the literature about adopting and implementing the schema to a preservation system is a decade or more old. In 2010, the National Snow and Ice Data Center and Data One, or the Data Observation Network for Earth, reported using PREMIS to revise and improve their in-house preservation metadata. In 2010, Donaldson and Conway observed the adoption of PREMIS at Florida Digital Archive of the Florida Center for Library Automation, or FCLA. They observed developers' processes and noted that, quote, use of the PREMIS data model and data dictionary requires adaptation. Clearly identifiable steps exist in the selection of PREMIS entities and the semantic units during the PREMIS implementation process. There are additional steps involved in the PREMIS implementation process after choices about entities and semantic units have been made, and the nature of the PREMIS implementation process is iterative, unquote. And finally, they noted that seemingly innocuous decisions by developers had real implications for preservation. We do have one more recent example of an institution adapting their model to PREMIS. In 2019, O'Sullivan et al. Reported that the proprietary digital preservation platform Preservica, which began in 2006 with an extensible information package-based data model, or XIP, decided that the needs of users required them to move to a PREMIS model. And they were generally successful, but because they had so many live users and so much existing data in their system, which if any of you are PREMIS users, you would be aware of this, this was no small feat. They found that they were able to reach level 2 conformance, as in export as PREMIS, but not level 3 conformance to PREMIS. Current academic articles address individual institutions' attempts to implement additional tools for PREMIS and use PREMIS for web archiving. The University of North Texas developed the PREMIS Event Service, an open-source API-based modular software that allows users to log, store, and query PREMIS events. Professionals have been puzzling out how to use PREMIS for web archiving, often trying to map other schemas to PREMIS. Romaniuk assessed the feasibility of using PREMIS with XMP for archiving the Perseus digital library at Tufts University and found some limitations to using the two schemas together because XMP metadata was attached directly to digital assets, and PREMIS is designed to live separately from the objects to which it applies. Web archiving topics are likely to continue to be an important topic for digital preservationists, so I expect to see more articles on PREMIS and standards for web and email archiving in the future. Thank you for listening. For more information, please see the references on the following pages.